Let's consider the probabilities of complements or complementary events. If we consider the experiment of rolling a die, our event we're going to say is rolling a 6. Rolling a 6. So what would be the complement of that event? Well, that would be rolling anything that's not a 6 or not rolling a 6. Remember from our notation, we use this little dash to mean not a 6. So if our event is a 6, then the complement of that event is anything else that's not a 6. So if we consider the probability of each of these events, the probability of rolling a 6 is 1, because there's one favourable outcome, a 6, out of 6 total possible outcomes. So if we consider the probability of our complement, it's the probability of getting something that's not a 6. So that's a 1, 2, 3, 4, or 5. There are 5 favourable outcomes out of 6. So if we have a look at the probability of our event and its complement, the probability of rolling a 6 plus the probability of rolling not a 6, or the complement of a 6, is 1/6, 1 out of 6, plus 5 out of 6. 1/6 plus 5/6 equals 6 out of 6, or 1 whole. And this is logical because if we think about another way of writing a whole, that's 100%. That means the chance of us rolling either a 6 or something that's not a 6 is 100%. Nothing else that we can roll. Either we roll a 6 or we roll something that's not a 6. There's a 100% chance of us rolling one of those two possibilities. If we consider tossing a coin, we consider our event to be tossing a heads. What is the complement of that event? Well, it's not tossing a heads. So heads with a dash. Or another way of writing that is tails. They're complementary events. Heads and not heads, or heads and tails. They are complementary events. So if we consider the probability of tossing a head, we know there are two outcomes, heads or tails. They have an even chance of each outcome, so the probability of tossing a head is half. And our probability of tossing a tails, or not a head, is also 1/2, because there's one tails out of two possible options. This is just two ways of writing the same thing. Something that's not a head is a tail. So if we consider the sum of those probabilities, the probability of tossing a head plus the probability of tossing tails is probability of head was 1/2, plus the probability of tails was also 1/2. So we have a 1/2 plus a 1/2, which is 2 halves or 1 whole. Again, this makes sense because our two possible options are head or tails. There's a 100% chance that if we toss that coin, we'll get heads or tails, except for the really, really rare circumstance where they land on their sides, but we're not going to consider those for this calculation. We'll just consider the possibility or the probability of getting a heads or a tails. And because there are only two options, there is a 1 or certain chance that we're going to get either heads or tails. When we add probabilities together, probabilities of complements, they will always be equal to 1.